Welcome to the Decode Factory. Today, we are going to decode the latest podcast featuring Jensen Huang and Cleo Abram. You don't need to watch this entire 1 hour, 3-minute podcast. This channel exists to save your time. In the next 7 minutes, we'll give you every important idea, every key moment, and everything Jensen Huang and Cleo Abram discussed. The conversation starts with a powerful question about the future. Cleo Abram asks Jensen Huang, the CEO of NVIDIA, how we get from the robots we have today to the future world he envisions. Jensen doesn't hesitate. He tells her that everything that moves will be robotics someday. He explains that NVIDIA invested tens of billions of dollars into this vision long before it became a reality, simply because they believed in it. Cleo sets the stage by explaining who Jensen is, the man leading a fundamental shift in how computers work. She tells him this interview won't be about finances, management style, or politics. Instead, she wants to create an optimistic explainer video about how technology can make the future better. Jensen laughs and claims he is the worst person for an explainer video, but Cleo insists he is the best. They dive straight into the history of NVIDIA to understand the present. Cleo asks about the key insights in the 90s that led to the modern GPU. Jensen explains that in the early days, they realized that while 90% of a software's code runs sequentially, one step after another, the remaining 10% does 99% of the actual processing work. That 99% could be done in parallel, all at once. NVIDIA was built to solve the problems that normal computers couldn't by creating a processor that could handle massive parallel tasks. Jensen shares a favorite analogy involving the Mythbusters. He describes a robot shooting paintballs one by one to represent a CPU versus a massive machine shooting thousands of paintballs simultaneously to represent a GPU. This parallel processing power was first unlocked for video games, which Jensen calls a simulation of virtual worlds. He admits they chose gaming because they loved it, but also because it was a huge market that could fund the massive R&D budget needed to create new technology. Cleo brings up a fascinating concept, the GPU as a time machine. Jensen explains that this means letting people see the future sooner. He tells a story about a quantum chemistry scientist who told him that because of NVIDIA, he could do his life's work in his lifetime. By making simulations run millions of times faster, researchers can effectively travel through time, seeing the results of complex simulations, like weather predictions or virtual cities, before they actually happen. The conversation shifts to a critical turning point, the invention of CUDA. Cleo explains that early researchers had to trick GPUs into thinking their scientific problems were graphics problems just to use the power. Jensen realized they needed a better way, so they built CUDA, a platform that let programmers speak directly to the GPU. He admits it was a strategy based on reasoned hope, building it before they knew if anyone would come. That bet paid off in 2012 with AlexNet. Cleo describes how 3 researchers used NVIDIA GPUs to train a neural network that crushed a computer vision competition. This was the big bang for modern AI. Jensen recalls seeing AlexNet and realizing that if a computer could learn to recognize images, it could theoretically learn anything. This realization prompted NVIDIA to reinvent the entire computing stack, building the massive supercomputers like the DGX that power the AI revolution today. Cleo asks why it took a decade from that 2012 breakthrough to the explosion of AI we see now. Jensen reflects that while it felt long, there was never a reason to stop because their core beliefs, that parallel computing was the future and that deep learning could scale, never changed. He says the last 10 years were about the science of AI, but the next 10 will be about the application science of AI, applying this intelligence to biology, climate, robotics, and more. This leads perfectly into the topic of physical AI, or robots. Cleo notes that we are on the verge of a big bang moment for robots. Jensen explains that up until now, robots had to be trained in the real world, which is slow and dangerous. But now, with NVIDIA's Omniverse, robots can be trained in digital simulations that obey the laws of physics. He introduces Cosmos, a new world foundation model. Just like ChatGPT learned from text, Cosmos learns from physical laws: gravity, friction, inertia. Jensen paints a vivid picture of the future where everyone has their own R2D2. It might not look like the droid from Star Wars. It might live in your smart glasses, your phone, or your car, but it will be a constant, intelligent companion that grows with you. He asserts again, everything that moves will be robotic. Cleo pushes back gently, asking about the risks. She mentions bias, toxicity, and safety. Jensen acknowledges the entire spectrum of concerns, from AI hallucinating fake information to safety-critical failures in self-driving cars. He compares the solution to aviation. Just as planes have triple redundancy and pilots watching pilots, AI systems need to be architected with layers of safety and community oversight. They discuss the physical limits of this technology. Jensen identifies energy as the only true constraint. He shows Cleo a new Blackwell chip, explaining that while it is 10,000 times more energy efficient than the first AI supercomputer he delivered to OpenAI in 2016, we still need more efficiency to keep scaling. Cleo asks a technical but crucial question about specialization. Should chips be designed for specific AI models like transformers or stay general? Jensen is firm, stay general. He believes that innovation is messy and unpredictable. If they had built chips only for the AI of 5 years ago, they wouldn't work for the AI of today. He wants to build a platform where inventors can swim in the soup of new ideas. Towards the end, Jensen offers advice to the audience. He tells students that the most important thing they can do right now is learn AI. He urges everyone to get an AI tutor immediately. Just as his generation had to learn to use computers to do their jobs better, this generation must learn to use AI to do their jobs better. He says this shouldn't make us feel obsolete, but superhuman. Cleo ends on a personal note. She admits she is afraid of flying and was thinking about her own funeral on the bumpy flight over. She hopes people will remember her for her optimism. She asks Jensen what he wants to be remembered for. Jensen pauses and says simply, "They made an extraordinary impact." He hopes future generations will look back and realize that this company, which they knew for video games, was actually at the epicenter of revolutionizing digital biology, robotics, and the very fabric of how we understand the world.